the even and odd components of a signal. If we have a signal ft, we can separate it into its even and odd components, where the even and odd components are given by this equation. The even component is given by 1 over 2 of ft, the original signal, plus f minus t. And the odd component of a signal is given by 1 over 2 ft minus f minus t. Okay, so that means that if we have a function or a signal ft, we can separate it into the even and odd component by finding these values. The even component is this equation and odd component is this equation. So let's say we have any function, then we want to find the even component. So from this equation, we can see that we already know what is ft, the original signal. So let's say, any signal ft, we already know it. Then we need to find the f minus t. Then from there, we can find the even and the odd component. So let's say we have this, for example, we have this signal, just a simple signal that looks like this. So this is ft. Let me draw this again. So we have, let's say we have this signal or this function ft, magnitude 4, let's say from 0 to 2, right? So we want to find the even and odd component. So we already know ft, then we need to find out what is f minus t. So how do you get f minus t? F minus t is just this signal reflected along the y-axis. So let's draw that. It's just a simple one. It's just a signal that is reflected along the y-axis. Oh dear, let me draw this properly. I am not good at drawing sketches. Okay, let's try this again. Okay, so we have this. Right, this is it's 4 from minus 2 until 2. It is just this signal reflected to the left hand side. Okay, so this is f minus t. Yeah. So now, if we want to find the even component, what we need to do, we need to find ft plus f minus t and then divide it by 2. So let's do that. So that means we have a signal that looks like this. How do we find it? We need to go from left to right to make it easier for you. If we look from left to right, at this point for ft, there's nothing there, right? This is point minus 1, this is point 1, this is point 2. Okay, let's take that point by point. If you see here, ft from left, there's nothing there, 0. For f minus t, there's nothing. As we come from the left to the right, as it approaches the point t equivalent to minus 2, the value is 0 here. So what you're going to have at that point, minus 2, okay, we'll have 0 until the point minus 2. Then you see that there's still 0 there, but there's value 4 here for f minus t. So it's 0 plus 4 is 4, divided by 2 is 2. It's positive 2. So let's say that is there. This is 2, right? So that as we go from left to right, okay, remember always go from left to right. You see, as we approach, okay, from left to right, we pass t equivalent to minus 2, and then we approach t equivalent to 0. So this is the same value here, and that is remains 0 there. So you have the same value up to point t equivalent to 0. Just before t equivalent to 0, we'll have the value 2, but the exact time t equivalent to 0, we have the value of 4 plus 4, which is 8, divided by 2 is 4. So you have that point, right? Now, as we pass t equivalent to 0, so we have here is 4, but here is 0. And divided by 2 is 2. So you see that it is 2. as we pass t equal to 0, we'll have 2, and that value continues as we approach t equal to 2. We still have the value of 2, but at the exact point t equal to 2, you'll have there, because we have here 4 plus 0, then after that is 0 and 0. So you have that one. That's okay. So that is F even, right? So now for F odd, okay, we need to subtract. You see here, ft minus f minus t. So we need to take that minus that. So again, we go from left to right. Okay, we go from left to right. 0 and 0. So for 0 and 0, we have 0. Then at this point, just at this point, we have 0. Minus 4 is minus 4. Divide by 2, so it's minus 1. Sorry, it's minus 2. Minus 4 divided by 2 is minus 2. Let's say minus 2 is there. So there is minus 2. So we have that. Okay. And then that value will continue as time approaches 0, t equals 0. Then at that exact point, exact time, t equivalent to 0 will have 4 minus 4, which is 0. So it's somewhere there. Then as it passes t equivalent to 0, right after, we'll have 4 minus 0 divided by 2. So that is positive 2. So we have that value. And then that value continues until that point when t equivalent to 0. And then after that, it is 0. So that is the odd component of this function. Now, if we want to check whether we can check whether we get the right odd and even component. How do we check? It's just by adding. Okay, we do the reverse. That means we add this to this, we should get this signal, right? So let's try to do that to check that we get the right signal, the right sketch of the components. Yeah. So again, always go from left to right. So if you see these two signals, yeah, so from left to right, as we approach minus 2, we have 0 and 0, so we have 0. Then at this point, we have 2 plus minus 2, so you have 0. So you have 0. So this one continues to be 2, this one is continues to be minus 2, so we have minus 0. Okay, and then at point t equivalent 0, what happens? Just before we have 2 and minus 2, but just after we have 2 and 2, which gives you 4, right? And then it continues. We have 2 and 2, so we have continued to have 4, and then time t equivalent to 2, so you have 0, and after that, so this is okay. So this looks is the same as this, so that means this is correct and this is correct. Okay, that's how you check for the sketches of the even and odd components. If it's not sketches, if it's numerical calculation, you can check the same method. Okay, so we have ft. It is composed of the even and odd components, where the even components is given by this equation and the odd components is given by this equation. And I've shown you how to sketch the even and the odd, and how to check whether we've got the correct sketches. Okay.